All right, so looking at the different problems here in our classwork, basically all I'm going to do here is I'm going to go through most, if not all of these problems. And I would suggest that, you might listen and go through one of the problems with me and just listen along, but then pause the video and just see what you can do. Try the problems out, see what you can do, and then you can kind of fast forward, you can pause, you can see if you're getting them right, see if you're getting them wrong, or if you just want to go through each problem. If you're still not getting it, you can listen to me talk over each one of these problems, but don't feel like you have to stay at the exact same pace. You can work through them and kind of check your answers working through the video. So number one, these problems are all numerical. So you certainly could just plug them in your calculator or just evaluate these separately, but we're going to do these with the lens of the exponent properties. So I'm going to go a little bit quick through them, but remember, you can always just rewind me or pause me. So first one, -3 squared times -3, and this would be to the first. So if we use those exponent properties, we're simply saying the base is -3, and since I'm multiplying, I'm going to add. So I'm going to get -3 cubed. And there's my answer if I'm just using exponent properties. Of course, these are numerical, so I could evaluate, right? So most people just want to say, all right, well, -3 times -3 times -3, I can actually just give that answer, right? So that is going to equal, -27. Next one here is this is a power of a power property. So you can see I have a power, but it's raised to another power right after that. So that property is always going to be to multiply the exponents. You can kind of think of those exponents being right next to each other. And since they're next to each other, I'm going to multiply those together. So now I'm going to have 2 to the -6 because I'm multiplying. But then we have to say, typically in math and when we're dealing with these expressions, we don't want, not all the time, but most of the time we don't want negative exponents. Or sometimes the problem might say, don't give me negative exponents. So if I did that, this would equal 1 over 2 to the +6. Look back at the properties that we talked about. And then, again, I can say 1 over 2 to the 6. Well, I know what 2 to the 6 is. 2 to the 6 is 64. So this is 1 over 64 is my actual numerical answer. So the important part here is not necessarily just, well, I can get 1/64. I can just pop this into my calculator and it just tells me it's a decimal and I can change it into a fraction. But actually this logic right here of using the exponent properties to break this down and get 1 over 64. Okay, next one. C, we have 6 to the -1 over 6 squared. So that is going to be a division problem. So we're going to take that and we're going to subtract the exponents. I'm going to take -1 and that's -2. So this will equal 6 to the -3. If we kept going with that, then I would say that's 1 over 6 to the +3 now. And I could keep on going as far as I want. So I can figure out 6 cubed, which is 216. This is 1 over 216. If I kept going on it. All right, next one. I got -3 to the 4th, right? And there's really no property here. It's just -3 to the 4th. So if we were to evaluate that, that's really the only thing I could do here. Is -3 to the 4th, -3 times -3 times -3 times -3, right? So that's going to be a +81. Part E might be a little bit tricky because we have -5 to the -2. The question in this problem is, what is the base of this power right here? We can rewrite this problem because there's really no parentheses in here like that. Because there's no parentheses, we could just think of this problem as really -1 times 5 to the -2 is really the exact same thing. Now, if we look at 5 to the -2, I know that I could take that and I can write that as a positive exponent. I know that this right here is going to be 1 over 5 to the +2. right? Because of the negative exponent property. And then I could just take the negative 1 from the left and bring that down. So I have a negative 1 times a 1 over 5 squared. So if I keep doing that, then I'm going to have negative 1 times basically 1 over 25. And then my answer would be just negative 1/25. Okay. Next one, F. So this is one where you can kind of use that. We have a negative exponent with a fraction. You can think about it in a lot of different ways, but the easiest to go ahead and do this is the one property that we talked about, which is if I have a negative exponent out here, and let's say I want to make that positive, let's make it a positive 3, I can do that if I take everything in the fraction and I just flip both things. The numerator becomes the denominator and then vice versa. So this would become a 5 over 2. And so I have 5 over 2 raised to the third power. And what this means is both, if I take this cubed right here, that's going to apply to the top and it's going to apply to the bottom. So I could write this problem now as 5 raised to the 3 over 2 raised to the 3. And if I keep on going on that, I can go ahead and evaluate those exponents if I want to. 5 cubed is 125 and 2 cubed is 8.